Hello, students. Today, lecture 2, number 2, wastewater characteristics, wastewater treatment methods, biological wastewater treatment in natural conditions. Okay, let's start. Introduction. Wastewater is defined as any water that has been negatively affected in quality by humans. Wastewater is comprised of liquid and solid waste that is discharged from domestic residents, commercial properties, industrial plants, and agriculture facilities or land. Wastewater contains a wide range of contaminants at various concentrations. Characteristics of wastewater. The three main characteristics of wastewater are classified below. Turbidity, color, odor, total solid temperature. Chemical characteristics due to chemical impurities, chemical oxygen demand, total organic carbon, nitrogen, phosphorus, chlorides, sulfates, alkalinity, pH, heavy metals, trace elements, priority pollutants. Biological characteristics due to contaminants. Biochemical oxygen demand, oxygen required for nitrification, microbial population. Wastewater characteristics, as well as water treatment process, are important for every environmental engineers to understand. Our an environmental exam review course truly reviews the characteristics of wastewater. Physical characteristics of wastewater is color, odor, temperature, turbidity. Color. Fresh sewage is normally brown and yellowish in color, but over time becomes black in color. Odor. Wastewater that includes sewage typically develops a strong odor. Temperature. Due to more biological activity, wastewater will have a high temperature. Turbidity. Due to suspended solid in wastewater, wastewater will have a higher turbidity or colorness. Chemical characteristics of wastewater. Wastewater contains different chemicals in various forms as mentioned below. Chemical oxygen demand. Code is a measure of organic material in wastewater in terms of the oxygen required to oxidize the organic materials. Total organic carbon stock is a measure of carbon within organic materials. Nitrogen. Organic nitrogen is the amount of nitrogen present in organic compounds. Phosphorus. Organic phosphorus in protein and inorganic phosphorus. Chlorides, sulfates, heavy metals, mercury, lead, zinc, cadmium, copper, nickel, silver, and others. Biological characteristics of wastewater. Biochemical oxygen demand. What is the amount of oxygen needed to stabilize organic matter used in microorganisms? Nitrogenous oxygen demand. Note is the amount of oxygen needed to convert organic and ammonia nitrogen into nitrates by nitrifying bacteria. Microbial life in wastewater. Wastewater contains the following microbes: bacteria, protozoa, fungi, viruses, algae, rotifers, and nematodes. The stage of wastewater treatment. There are three main stages of wastewater treatment process. Aptly known as primary, secondary, and tertiary water treatment. In some applications, more advanced treatment is required, known as quaternary water treatment. This stage deals with parts per million to parts per billion levels of contamination and often involves oxidation or fine filtration process. Each of these stages tackles different pollutants, with water becoming cleaner as it removes through the phases. Wastewater can be treated to three standards: primary, secondary, and tertiary. Primary minimal treatment involving floating and the settlement to separate solids and the liquids and the disposal of clarified but still contaminated effluents, such as septic tanks and the composting toilets. Secondary, more advanced treatment using air and the biological process to decompose the solids and the chlorine to disinfect the liquid to a standard safe for irrigation, such as aerated wastewater treatment systems. Tertiary, highly advanced systems that use air and the biological process as well as membrane and the ultraviolet disinfection to treat wastewater to a very high standard, such as membrane filtration and advanced aerated wastewater treatment systems. What is primary wastewater treatment? During primary treatment, wastewater is temporarily held in a settling tank where heavier solids sink to the bottom while a lighter solid flow to the surface. Unsettled phase material are held back while the remaining liquid is discharged or moved through to the more secondary phase of wastewater treatment. These large tanks are also often equipped with mechanical scrapers that continually drive collected sludge in the base of the tank to a hopper, which pumps it to sludge treatment facilities. What is secondary wastewater treatment? Secondary treatment of wastewater works on a deeper level than primary and is designed to substantially degrade the biological content of waste through aerobic biological process. Completing secondary wastewater treatment allows for safer release into the local environment, reducing common biodegradable contaminants down to safe levels. It is done in one of three ways: by filtration, aeration, oxidation ponds. Biofiltration uses sand filters, contact filters, or trickling filters to ensure that any additional sediment is removed for the wastewater. Aeration is a lengthy process which increases oxygen saturation by introducing air to wastewater. Typically, the aeration process can last for up to 30 hours, but it's very effective. Oxidation ponds, typically used in warmer climates, this method utilizes natural bodies of water such as lagoons, allowing wastewater to pass through for a set period before being retained for 2 to 3 weeks. What is tertiary wastewater treatment? The aim of tertiary wastewater treatment is to raise the quality of water to domestic and industrial standard, or to meet specific requirements around the safe discharge of water. In the case of water treated by municipalities, tertiary treatment also involves the removal of pathogens, which ensures that water is safe for drinking purposes. Biological wastewater treatment, despite the abundance of well-mastered methods of physical and physical-chemical treatment of contaminated water, methods of biological treatment are a dynamically developing branch of applied ecology, and in the future can solve urgent problems of wastewater disposal. Biological processes in living organisms are accompanied by the transformation of chemical compounds and the release of energy. Certain types of microorganisms implement not only the well-known cycle of biogenic nitrogen transformation, but also the cycles of transformation of other biogenic elements, sulfur, magnesium, chromium, iron, and most of the elements involved in redox reaction. It is also important that process with participation of living organisms suggests several alternative possibilities for the biotransformation of elements. Therefore, for industrial implementation, one can almost always choose the most convenient way. Biological wastewater treatment, conversion of colloidal and dissolved organic substances into mineral compounds due to the vital activity of bacteria. The process of biological purification are in many respects similar to the process of self-purification in natural reservoirs, intensified by the use of systems of engineering structures such as aeration tanks, biological filters, biological ponds, irrigation fields, aeration fields. Biological wastewater treatment is one of the most common methods of wastewater treatment in preparation for discharge into water bodies. Aeration tank method called activated sludge. The wastewater is put into a large rectangular tank into which air is pumped. So microorganisms in the wastewater use the oxygen in the air to degrade the organic waste. In effect, the microorganisms use the waste as a food source. Okay, thank you for attention.